Hi, welcome to the lecture on the standard normal distribution. So we've talked before about discrete distributions in the previous section. In this lesson, we're looking at continuous distributions. And there's really just one continuous distribution we look at, and that's the normal distribution. With discrete distributions, we listed all of the possible values with their probabilities. But with a continuous distribution, we have too many possible values to do that. So instead of listing all of them individually, we show them either in a formula or in a graph. Now, there are infinitely many possible values that the random variable could take on. So because of that, the probability that the random variable equals any one particular one of those values is 0. An example I sometimes use is it's like if I had a grain of sand somewhere on a beach somewhere and asked you to go pick up a grain of sand somewhere on a beach, the probability that you'd find the same one I left there would be essentially 0 because there's practically infinitely many grains of sand. So instead of looking at probabilities that the random variable equals a particular value, we look for the probability that the random variable is in an interval, like between -1 and 1. So it's important that we study the normal distribution for a couple of reasons. One is it is often a good fit for real data. A lot of times data actually does follow a normal distribution. Also, it's used as the basis for statistical inference. A lot of the stuff we're going to do from here on out relies on the normal distribution. So this is kind of the first introduction to that. So the normal curve, the bell curve, looks a lot like this, where it's bell-shaped. It's symmetric, so it's symmetric about the middle here. And it's got one peak, so it's unimodal. And that one peak is always at the mean. The exact shape depends on its mean and its standard deviation. So in general, normal distributions can have any mean, negative or positive or 0, and the standard deviation can be any value as long as it's greater than 0. Now, the standard normal distribution is the particular normal distribution with a mean of 0 and a standard deviation of 1. Now, there are any number of normal distributions defined by mu and sigma, but the standard normal is the one that has a mean of 0 and a standard deviation of 1. Anytime you're working with a normal distribution with a standard deviation of 1 and a mean of 0, it's going to use the variable z. Usually if it's not z, they'll label it as x, but anytime you see z, you know we're talking about the standard normal distribution. So this is what the standard normal distribution looks like. It's got the bell-shaped, the mean is 0, so the mean is underneath the peak. And, we usually sketch the values out from -3 to 3 because most of the curve is contained there. But the values actually go out from -infinity to infinity. We just don't usually sketch them beyond -3 to 3 because the area past that gets really small. So I've been talking about area, but there's a relationship between area and probability. So if we're looking for, say, look back at this slide, the area greater than 0, that's going to be the same as the probability greater than 0. So greater than 0 would be half of the area, and this half of the probability. So it's possible to use a lot of different tools to calculate standard normal probabilities. There are tables, there are calculators. But we're going to use StatCrunch because it's really, really easy. You'll get the right answer, and I'll be able to see how you got your answers so I can give you partial credit. So the first example, suppose we want to find the probability that z is between -1 and 1. So first thing, I want you to make sure that you're comfortable with this notation. This notation means that z is greater than -1, but also less than 1. So that notation means between. And remember that for continuous distributions, the probability equal to a particular number is 0. So it doesn't matter for the continuous distributions whether we put less than or equal to in there. All right, so we're going to go over to StatCrunch now. Yeah, so going over to StatCrunch, so I'm just logged in here to MyStatLab, and from there click on StatCrunch on the left and visit the StatCrunch website. And we're going to open StatCrunch. And from here, we're going under Stat, Calculators, Normal. And here, so there's the standard and then there's the between. We're using between because we want the probability between. This actually already has -1 to 1 typed in here. We're going to leave this as 0 and 1. So it defaults to 0 and 1. So we're going to leave that there. If this were -2 to 2, we just change those and hit compute. But we want -1 to 1. We hit compute, and it tells us that the probability is 0.6827. Okay, so you're going to copy that and follow the instructions there. Copy that and paste it into your homework, and then I can see what you've done. Okay, notice that here it gives you the sketch between -1 and 1. That means this is the area we're looking for. And I want you to be sort of familiar, be on the lookout for whether this makes sense to you in terms of the area. So 68.26% of the area. Do you see that this looks like it's about 68% of the shading of the area from -infinity to infinity? Okay, so that'll just kind of help develop your intuition there. All right, so that's our first example. And I want to point out here though that this says it's X. We're using Z though, so I will expect to see you write that as Z because we're using a mean of 0 and a standard deviation of 1. Okay, so now let's find the second example, the probability that Z is less than -2.85. So back to our normal calculator. So we said less than -2.85. Before we were working with the between window, now we're working at the standard window. You can change this less than to greater than as you need to. This says -2.85. We compute. And you see this tiny little shaded area over here is 0.0022. So that tells us the probability that Z is less than -2.85 is 0.0022. Third example, the probability that Z is greater than -1.24. So we're changed less than to greater than. -1.24, and we get an area of 0.8925, and you can see that that's 90% almost of the area under the curve. All right, So that's as hard as those get. Suppose that we wanted to work backwards. Suppose instead of wanting to find the probability given a certain interval of x, now they want you to find the z value that goes with the probability. So they'll give you the probability and ask you to find the value of z. And we're going to do these in StatCrunch too. So the first problem, find the value of z so that the probability less than z is 0.4. So 0.4 is important here, and also this less than. Okay, so if we go back over to StatCrunch, we're looking for the value of z with less than, so we change that to less than, the value being 0.4. So we can actually change this probability to 0.4 and hit compute. And this tells us that this value of z is negative 0.2533. All right, so the value of z with probability less than z being 0.4, this area is 0.4. This value of z down here is negative 0.2533. Let's do the next example. Find the z-score shown in this picture. So in this picture, you can see 0.15 is this shaded area, this shaded blue area, and we're looking for the z that goes with that. So we've got 15% of the area to the right. So change that from less than to greater than, and change that to 0.15. Click compute, and it tells us this area here is 15%. That means this value of z is 1.0364. Finally, two values that separate the middle 75% from the remaining 25%. So for this one, we want two values. One of them is going to be negative and the other one is going to be positive, where 75% is in between them. So here we're looking for the between one as opposed to the standard one. And we're looking for two values of z with 0.75 in the middle, so we change the probability to 0.75, and it tells us that the two values of z are plus and minus 1.1503. So some notation you need to be familiar with. Something like p with a subscript of 80, that means the 80th percentile. That always gives you the value of z with 80% of the area to the left. So whatever that subscript is there, if it's 60, that means the 60th percentile. And it's always to the left. That's just how that's defined. So the subscript p always tells you how much is the area to the left. So anytime they say p of 80, that means go over here and go to the standard one, and it's always going to be less than. So 0.8. If it's 0.6, that's 0.6. Okay, always less than with that p notation. The opposite one is z with a subscript. So z with a subscript of 0.2, for example, says here's the value of z with 20% of the area to the right. That's just how this notation is defined. So anytime you've got a z, change that to greater than, and if it says 0.2 to the right, that's what that is. If it says 0.05 to the right, make sure it's greater than, type in your 0.05 and hit compute. Okay? So, just to summarize, two major kinds of problems. The first one is they're asking you to find a standard normal probability. For that one, you're going to enter the values of z and find the probability. For the inverse probability, they're going to give you a probability and ask you to find the values of z that go with that. For those, you're going to change the probability. You're going to change the value over here to find the inverse normal. All right, so that's it for this lesson.